do a quick tutorial on a Punnett square and how you use it. We're going to start by talking about Mendelian genetics, which means that one trait, one gene. And the first word that we need to know about is we need to know about an allele. And what an allele is just the alternative forms of a gene. In the picture, what it shows you is a wrinkled pea and a round pea. So each one of those is an allele. Round is an allele. Wrinkled is an allele. You get your genes or your alleles from your parents, and each parent gives you one allele for each trait. When we talk about alleles, we could talk about them being recessive or dominant. And what a dominant allele is if they're present, they're expressed. A recessive allele is only expressed if there's no dominant allele present. So when Mendel did his experiments, these are some of the traits that he looked at. So the first one we've already looked at is round versus wrinkled. So round is a capital R, meaning that it's dominant, and wrinkled is the recessive. So I use a lowercase r. So whenever I have a capital R, the seed's going to be round. Another trait he looked at was pea color, and yellow is dominant over green. So you have a capital Y for the dominant and a lowercase y for the recessive. And each one of these is just another trait that he studied. Okay, so a parent donates half of their genetic information. When we're looking at a Punnett square, it's used to determine which half could possibly be donated. So since a parent, we'll say this is a parent, each has two different alleles. This one has a capital R and a lowercase r. It's possible that this is the allele that gets donated to the baby, or it is possible that this allele gets donated, but the parent is not going to give you both of them. Mom gives you one and dad gives you one, so then you have a complete pair. So if we say a genotype, or the types of genes that they have, are going to be two alleles. So we're going to say in this case that dad is a big G and a little g, and mom is a big G and a little g. Since they're two different ones, we call that heterozygous. And the way we fill in the Punnett square is we use these blocks. These top blocks and these side blocks represent the allele that the parent possibly could give. So we can put dad could possibly give his capital G, or the other thing he could do, he could possibly give his lowercase g. So what I have is I take one G and I put it here, and the other G and put it here, and only one allele goes in each one of these outside boxes. Mom's going to do the same thing. She could give a capital G, or she could give a lowercase g. And that's how you put the parents on the Punnett square. It doesn't really matter if you put dad up here or on the side, or mom up on top or on the side. It ends up working out the exact same way. I have it set up where I have the male on this side and I have the female on this side, but it doesn't have to be that way. So once we have it set up, we're going to try to determine the possible offspring. The babies are down here in these center blocks. And the way that I end up putting those in is I take this and I bring it down to every block below it. So I'm going to take my G and I'm going to put it down, and I'm going to bring it down. And I do the same thing with the lowercase g. I bring it down and I bring it down. And then with the mom, I'm going to bring them across and bring them across, because each baby is going to need to have a set. And as soon as I put mom's information in there, that baby has a full set. That baby has a full set. That baby has a full set. And that baby has a full set. So we have 4 possible babies. It doesn't mean that when pea plants reproduce, they're only going to have 4, or they're going to have 4 every single time. This is going to give me a probability of what types of babies they possibly could make. So once we have this set up, we could talk about a phenotype, Okay, a genotype is the type of genes. So a genotype would be this: big G, or big G, or little g, little g. Those are all genotypes. A phenotype is what the baby's going to look like. So we talked about dominant and recessive alleles a little bit earlier. This has a dominant and a dominant. So this allele is green and this allele is green. So when I put them together, the baby's going to end up being green. This allele is saying yellow and this allele is saying green, but green is dominant. So if it's present, that's the one that shows up. That's the one that's expressed in the phenotype. So it doesn't really matter if it's set up this way with a little g first or second. Both of these have a dominant allele present. So in either case, big G, little g, or little g, big G, they both have a phenotype of green. And then last, we have two lowercase g's. There's no green information. The only information that's here available for this baby is yellow. So the phenotype for this baby is yellow. And how we read this is we count. There are 3 green, right? 1, 2, 3 green. So out of 4 possibilities, so 75% chance of having a green baby. You only have 1 out of 4 are yellow. So you have a 25% probability of having a yellow baby. I hope this helped.